Hey John, good to get to stop by and see you.
Good to see you too.
Thanks for the Charlie that you built for me. I really appreciate it. Yeah, I wanted to talk to you a little bit about it and hear kind of like the trials and tribulations and sufferings you went through.
Well, I think part of it, we can talk from the very beginning.
Yeah, okay.
I think
That'd be interesting.
people kind of wonder where or how or some people always say it was done before.
Yeah,
If it was done before, where's it at, right?
yeah,
But originally, the initial issue came back in 2002, 2003, when I was shooting. The gun I had was a simple TRG 42, and they have a funny rail system. And at that point, there was no such thing as slope rails. No, you have a scope that had, at that time, 80 MOA of travel on it. You couldn't use half of it because it was on a level rail. Mm-hmm. And it didn't take very long after 1,000 yards that you were shooting further because you dialed out the scope.
right.
So the first thing I did is back in 2003, I built slope rails for my gun. So I was able to pick up full travel on that scope. It didn't take very long to go, it's still not far enough. The gun's still shooting. Mm-hmm. We don't have to, we're out of adjustment. So a few years later, I had changed positions. I started a company being this, and it was initially wrapped around armor, and then a simple little device looks just like this. This is a simple wedge. And my initial goal was literally only to add like 5 mil to the system. Because I wanted to say, in my head, I'm going, well, who shoots 2,000 yards? Who shoots 2,500 yards?
Right.
Versus lots of people shoot 1,000 yards.
Mm-hmm.
So I said, what I'm going to do is I gave you an optic that just goes click and it's 1,000 yard zero. Literally. Just, there's no dialing. Here's your 1,000 yard zero, now you can dial. And I figured, well, that would cover people for a while and a half.
Yeah.
Well, the first thing that happens is that standard materials, single glass components, at a low number of only 12 or 15 MOA, as you increase magnification, you get chromatic aberration. The color starts separating.
Okay.
Like prism, green, purple, it's all showing up. Right?
Yeah.
So you recognize that, well, I need to do a true achromat, 2 different classes, 3 different classes to get rid of that aberration. Okay. So this one ran into limits. Is it simple? Yep. Does it give me 1,000 yards? Yep.
Right.
It's still using on lesser powered scopes. 10x runs just fine. Okay. Rapid. All the alphas run this for all the point blank range components that we work with, or components. But then it was okay. Well, how do I get more? So then the next question was, I need 30 mil, and it only took about a moment and a half to recognize I can't build this at 30 mil. And how do I do it? Because the problem with building a 30 mil wedge is that it's going to take at least 2 pieces of different types of glass. Each one has to be ground and polished to its own angle, and not just any angle. They got to be precise because they interact together in order to have an output go down range. Well, each piece of glass then takes tooling. Well, anybody who makes custom tooling, you quickly realize there's money involved. Mm-hmm. Oh, if I'm going to make custom tooling, you can't buy 1, you need to buy 10. Well, all of a sudden, a single run on a prism, it quickly hits $4,000 or $5,000 to test a piece of glass, only to find out you're wrong. You got to redo it, you got to tweak it just a little bit. Oh, new tooling.
Yeah.
Do it all over again and start up again. So it can get very expensive. So then I said, okay, the easiest thing I could do is just fold it to the mirror. Now I think one of the things that needs to be understood when people say it's been done before, people use tanks for alignment, for looking at barrel droop. That's not what this is being done. I am moving the object relative to you. I'm not moving a reticle relative to the object, which now I have to raise the gun. No, I move the world out in front of it. It's a backwards thought. People can say, well, it's just a dumb, all you do is redo it. Well, yeah, but nobody did before that.
Right.
The term shoot at the clouds, aim at the clouds, is because you didn't have the elevation. You put your reticle on something higher up than dropping down to see where the shot went.
Right.
Yeah.
And
they had been known. I mean, sniper records went by 20 yard increments, 20 meter increments, tink, 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 a little bit back and forth, because they're all in the limits of optics.
Yep.
Okay. And if it had been understood that it was that easy, then why did they sit there for 20 years going 10 yard increments?
Right.
Someone would just produce that and said, boom. But we moved the world versus moving the reticle. Okay. And by doing that, I put this together, this is an original Charlie, original. So I could move it large amounts and just use a pair of mirrors to set my object somewhere else.
Sure.
An exact number. And therefore, all of a sudden I didn't have great limits. And why did that matter? Because I had a phone call come in from, I can talk about it now, the Canadian group that took the record. At that time I couldn't talk for a decade. Then the first order was for 30 mil. A week and a half later it was for another one for 50 mil. A week and a half later it was 70 mil. Well, the numbers were moving so fast, there was no way possible to build tooling to remotely do this. I'd have been in instantly $20,000, $30,000 worth of glass trying to meet those orders, and also the lead time.
Mm-hmm.
What, someone's going to drop everything they're doing to build tooling to make 10 pieces?
Right.
It ain't happening. And people don't realize how limited optics is in the United States now. It came close to going extinct. Maybe it's hanging in there a little bit and some new technologies, but this is not like it was in the 50s or 60s, where there was lots of people. California, Long Beach, all the optical places went under. And a lot of it has to do with environmental crap. Can't use acetone, can't use methylene chloride, can't do this, can't do that. Pretty soon all the can'ts, well, I can't make anything. Everybody thinks about what that means. But what we did was I started full mirror system here. And so therefore, this is a solid system. Because my original thought was I would just take one piece off and another piece in with a different mirror, with a new value. The only problem I found with that was that the left to right would tweak just a little bit.
Yeah.
And it's amazing how fast a minute or 2 minutes adds up. It gets there like now. Okay? So we recognized that we had to leave left to right set. Therefore, we could rotate the bottom and lock it, get pretty, and be very close. But it wasn't the same as trying to pull the whole device in and out. So these, technically, they can go 600, 800 MOA. And what eventually starts happening is the window, my view, starts being closed off because I'm looking lower and lower and lower for the object. So this edge starts moving up in my view, and I can't see it. And also, a lot of people, another thing, I'm going to digress real quickly here. As you put the optics on the scopes, scope A, manufacturer, is not the same as scope B, is not the same as scope C, and so on and so on.
We found that out.
In fact, you just got that right now.
Yeah.
The loophole, which you see on this gun, is very low.
Yeah.
But it could see 1300 MOA. Yours at 1.5 couldn't see 1200 MOA.
Right.
But the 2-inch allow you to see 1400 MOA.
Yeah, it's
And
definitely.
so how the scope takes and manipulates the image I've given it becomes a problem. The other problem with it too is that scope A versus B versus C. At the extremes, 1 mil is not 1 mil. If I compare Schmidt-Bender, Vortex, Night Force, and so on, at those extremes, a mil movement, or how this operates, is not the same mil. You have to shoot it at those values to get a true number. Because how the glass is taking and bending it is one thing. And also, I'm not completely sure, people always talk about tracking. I don't see very many tests where someone is taking their scope through full range track. Maybe a box, but that's not the same as 30 mil.
Right.
You know, did it track all the way up and down, fully, exactly 30 mil? Then the next question comes, as I hold on the reticle, I have a reticle that's based on a flat plane. Well, if I'm holding a view and I'm starting a mill, what am I doing? I'm creating an arc. Well, if I move my gun up and down, is that arc now the same on the reticle for distance? That'd be a question, because if I do a straight curvature and I go 1 mile and I go flat plane down, then I put the curvature of the center of that aim point and drop an arc, you're off by 15 yards rapidly. You're short. Well, 15 yard miscalculation on range in a mile, you missed. You're short, right? So that's why you have to do final prove out. Where does everything really sit?
Yeah.
Okay, and it doesn't matter if you have a wedge, you know, the Bravo or the Night Force. It doesn't matter. You need the number in the end for those extreme things, because what is the scope actually doing? Then, so we got to this, and the problem with this was that if I set it to a large value, let's say 400 MOA, and the scope's capable of 100 MOA, what do I do between 1 and 4? That's a big gap. That's a lot of space to go. Did you see where it went? You know, that's what you would do. You'd have to go send someone out there and skip that whole distance and go, well, did we get it? And as you talked about earlier, a little bit of wind, you started moving football fields of left to right hole, of, you know, the bullet's making a nice curve all the way to target because the wind's just really taking over. And also, you think about it, a 6,000 or 7,000 yard shot, that bullet's rising up 2,000 feet.
Oh yeah.
It's a different atmosphere.
It is.
It's a different wind pattern. It's different everything, right?
It is.
And it's kind of, if you ever have a still day where where it's still in the ground and start a smoky fire and let that thing go up. See how far up it has to go before all of a sudden it goes.
Yeah. Well, so in hot air balloons, that's how they steer. They spit and they watch the spit, and they lower down to that air current that's moving that way.
Yeah,
I found that out from being in a hot air balloon.
There you go.
Like, oh wow, okay, up in the air.
So what happens when the guy gets cottonmouth?
Yeah, so he had us spitting.
Right? We need spitters. Come on, where are they all at? But you need those final numbers. And back to, so we're talking about that gap. The gap in between. There's a few things that came out. One of the things I noticed is when I go to base, a brand new shooter, because one of the things I see with experienced people, a lot of times experienced people with capability, they're slow to look at new tech because they know it. But it's kind of like, okay, I can run a shovel, but I'll take the backhoe.
Yeah.
Now my experience says if I see a yellow line, don't cut through because it might be gas.
Right.
The average unexperienced guy wouldn't know that, but I can still apply my experience to tech and make it move, right? So what would happen on a base, the second they extended range, if I had a 10 mil, a low set one so it wouldn't go to the next county, the shooters would grab this, drop it on, and pull the trigger versus dial because of simplicity. I didn't lose myself. I didn't have to think about it. I just go click and pull the trigger. Because then I'm just shooting a reticle. It's there, shoot the reticle, done. I didn't dial, didn't do anything. So I always thought, well, what if I could make a device I could go, every click would be one reticle. So just making numbers easy. If I could see 10 mil, 10, 20, 30. Every time I click, I never turn the turret. I'm just shooting a reticle.
Yeah.
Now how fast is that? What's my mistake level? Right? Because if I got to turn a turret, and don't get me wrong, you got to turn turrets at times. There's places. But if I'm under duress, heavy engagement, time, I can't tell Mr. Elk out there, go, hang on, I'm going to range find you, get my dope, I'm going to dial, I'm going to da-da-da-da-da-da. It's an exaggeration, but how fast can I make it? If I can go click, I'm pulling a trigger, well, that's pretty basic, And back to lizard brain, the less I have to do, the less chance of me skipping a step by accident and go, I missed, and you go, oh, let's do it again. So I thought, well, what if I could make a dial that goes click, click, click? Okay, now there's a big difference between I'm going for effect 5, 10, 15, or whatever the reticle value is versus a guy who's going ELR. I set the first click within their range of their scope on the first set. Though they had 120 MOA on the scope, they can only dial 70.
Right. That was MOA Charlie you set up.
And I set that one, I set it up so that first click, they're still looking, they didn't go into a gap. Because what's the point? You got 70, I give you a 30 or 100. What do you do with 30 MOA? That's missing.
Right.
Well, 30 MOA is a long ways.
Yeah.
So I set the first one that it falls in that first gap, that you're usable. Then the next one I can go 100 now. Because you're already there now.
Right.
Now we're going somewhere.
Yep.
And So then it was, okay, how do I dial and make this real? We know the mirror's working. One of the big advantages of the mirror versus any of the wedges, and I didn't bring the wedge out here. You want to see an old versions of wedges. There we go, old versions of wedges, right?
Wow.
And is that these go above significant portion of the mirage off your barrel. A wedge is always looking at the mirage. And if I drop a wedge on this, it might see past this break, might. But I have a 30 mil unit, well, I can tell you what, that suppressor sitting there, 30 mils looking at that suppressor.
Yeah. It is.
And also, what got there first? The heat. Well, if I'm looking through mirage, how am I making the shot?
Yeah, that's hard.
It's really hard. This puts us far enough above that a large portion of that mirage is gone. So therefore you have an advantage of shooting without mirage in your system, okay? And I know there's arguments that, oh, our guys will never ever take more than 3 shots, and I've been told that. Our guys will never take more than 3 shots on the field. At 3 shots, they're out of there. It's like, damn, I'm not the smartest guy, but if you can control a battlefield that you know exactly how many rounds a guy is going to shoot per engagement, that's pretty good. I'm struggling with that, but if you're right, hats off to you. But what happens if you have to run 4, 5, 6, 7, 8, 9, 10, and it's getting so hot, I have mirage? Well, even if I'm still shooting, maybe not after, but now I'm shooting mirage, well, how effective am I being?
Right.
You know, so this doesn't make a lot of sense. I can look over the mirage. And I've had people tell me that just looking over the mirage is worth it by itself. You know, that even the LR guys shooting 4.16s said, you know, something the difference is, if 15 shots, I'm not looking through the mirage.
Right.
And you go, what's that worth to somebody?
Big help.
So now, you know, so then I go, okay, we know all those basics. It's obviously, this is the simple one to do, because technically, with a correctly built prism, you can make what you call Risley. It's a pair of prisms that you rotate against each other, and I can change elevation. And that works just fine. But it means I could have a sealed system or a gap, right? Because sealed systems, you make it fog in it, or you need a gap so it doesn't get fog in it, right? But now they operate together. They got to be locked to rotate counter to each other. Well, there's a little bit of mechanism, and now I got to rotate it exactly a number, and not only am I changing elevation, but every time I stop, the left to right has to be in place also, not just elevation.
You're right.
So, can it be done? Yes. Actually, does it save money? No, because now you've got 4 pieces of glass versus 2, and so on and so on. Also, if I'm going to see a muzzle brake and mirage at 30 mil, what do you think you're going to see at 60 or 90?
Right.
It's just going to get worse.
Yep.
Rapidly. Okay, so therefore, though I can do it wisely and I can mount it, I introduce other problems. Okay, it's not worth. I have an easier solution. Just use 2 mirrors. Okay, so then I want to move this piece through a range, and so what will, you know, this went through a lot of iterations. Each time I did it, there's a click. You know, I would gain something, but I would lose something. Okay, this one actually did pretty good, and you see it's pretty compact. If you feel it.
Yeah,
It feels very exact.
The one video you had it on the front when you were making the video.
The problem with this
Charlie.
unit though was, in one direction, it would be very precise, single digit arc seconds. Come the other direction, I could lose 1 minute. Now, 1 minute, and it's amazing how people will jump up and down about 1 minute, and you go, oh, it's a minute, it's terrible. Have you ever checked your scope at 120 MOA? Is it still 1 minute?
Right.
Is it 120 MOA, or is it 119, or is it 118, or is it 117? If you haven't measured, you don't know. And I'm pretty confident that exactly 1 MOA at 120, probably it's not happening. Okay, so here it's like, okay, I started at 100. If I have 1 MOA, that's what percentage? It's 1%. Thing is, if I go 200 MOA, it's still 1 MOA. Well, what scope out there does 200 MOA? There's only one other, right? The Genesis. If I go 300 MOA, still 1 MOA off. You go, as a percentage of range, 1 MOA at those values is you know, okay, at 1 MOA at 300, what, 0.03 or whatever it is. And you go, well, what's 0.3? So what's that worth? My wind error is bigger than that.
Mm-hmm.
My velocity spread at that point. I better have good loaded ammunition. I can't have no SD sitting there
Right.
at 10 or 12, right?
Yeah.
So there's
Makes
other
a big
things.
difference.
But when I asked people about would they accept it, it was a resounding no. And I didn't want to, I wasn't going to go and argue with them. But it was a market perception of 1 MOA is terrible, though you've never measured it and never ever got to these values, not even remotely close, right? And so then it's like, okay, what do I have to do? So the next version, I knew it was going to become bigger, but I needed to spread when I move a click. The error, I need to, simple geometry. I do not have a $500,000 gear down machine out here, hot machine out here, cutting a turret. I just don't. I don't intend to put one in place. Okay?
Okay.
And also, what would it look like in order to pull that off? Would the turret still be the same? Or how many turns do I'm going? And, you know, and does that exist? Yeah. You can, I don't know how much the scope, the Genesis scope, how it moves and it's successful, but as a user, do I want to turn the turret how many times, or do I go, here's my 100.
Right.
I'm
That's
done.
so much easier.
200, I'm done. You're still, where are you at? 300, I'm done. You know, oh, we're only 400. I have to bring it back to 100. I'm done. What are you? And then the question becomes, will I lose my brain? What rotation am I on?
Yeah.
How many am I into it? And and you know, I love the gimbal they have. It's obviously some good technology there, and it's repeatable. And right now they own the longest kill shot, right? So I can't take that away. But one versus the other, what's my user advantages? Okay. Now, one of the big advantages of all these technologies here is that the scope never moved. My cheek position never moved.
Right.
My shoulder position never moved. And when people talk about precision shooting, once you hit upper levels, how many people talk about shooter position? Shooter position. If you don't have shooter position and can't repeat it, you can't shoot. Oh, but I'm going to make a 5,000-yard shoot and completely change everything about my position. Change my change my this, change my shoulder, change that. And I'm going to say I have good shooter position? Well, I'd question that.
Mm-hmm.
Because both statements can't be right. You know, either shooter position is good or it don't matter.
Right.
Which one is it? This allows me to stay on shooter position and mine doesn't change. And even a tilting system, I'm moving the eyepiece up. I'm having to do something, and or if I have a tilting system, either this is rising or so high that it's rising, but where's the bell going?
Right.
It's facing
Yep.
the barrel.
That's why I picked your stuff.
You know, and is there a place for it? You betcha. Small numbers, knock your socks off, and so on. But I never thought, other than like the alphas, which are for semi-automatic, you know, or 600, 800-yard engagements in, and also they're already starting an inch and a half, 2 inches up. I never wanted to be on the barrel. I knew that from day one because like it's just too many shortcomings. You're just, and now what do you do?
Right.
And that's not a Band-Aid. It doesn't work.
Mm-hmm.
You know, so we wanted to stay above the system. So this one, even though it was a prototype, it is an operating system, and we've shot it. You know, that's why those numbers are out there.
Yeah.
Because we took it out and shot it. You know, and so that bringing us closer to today's stuff. The Delta had to go with it because at some point I'm looking at such an angle, I am looking at the barrel. You can't put 600 MOA on the system and not look at the barrel.
Right.
600 MOA is 10 degrees.
Yeah. I have to
is-
take the suppressor off when I start getting up in those ranges.
You start going up. So I want to look around the part. I'm going to look in one side, look around. This sits parallel. It is not angular to a system. So the offset is the center of this mirror to this mirror. It stays the same all the way out. Okay, so therefore, and if you can tell me you can hold an 1.5-inch group at 5,000 yards, more power to you. Okay?
Right.
But it's an offset, one offset, that's
Yep.
it. Now, the other thing about these kinds of add-on optics is they don't care what's behind them. I could put this on a holographic. Like, hey, it doesn't matter. It doesn't care what's behind it. Outside, you need to know where the limits are within the system.
Right.
But it doesn't care.
Sure.
It doesn't care what's behind it. You know. So the deltas got built. This is an original unit. It is as heavy as all get out. But that's where it started.
It is heavier.
Yeah. Okay. And interesting though, if you look inside, it's got a broken mirror.
Yeah, it does.
That was sent back to me after about 3 years, and it broke. And we made changes around the break to make sure, or do our very best to make sure it can't happen again, you know. And so then the delta goes on, looks around the part. But then you start running the same problems. I'm going window, 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 window into something, and it doesn't take long before misalignments start taking place.
Yes.
Up, down, tilt, and so on, okay? Because in this case, when I built a Charlie, I wanted to get to 70 mil, right? 300 MOA, or whatever, you know, let's say 300 MOA. Here we're talking about 1400 MOA.
Right.
So we are, you know, 20 it's a giant, 12 times larger in movement, okay? And usually when people talk about changes, you talk about percentage. 12 X's, that's a big, I mean, or let's see, 300, 8 X's is a big number, you know? And that's usually not the same device, and it isn't. So for us, we had to look, you know, I built yours, I made sure that I could make that swing. But an actual device for us is a new unit. So the new unit is about 3/8 of an inch taller, because I have to run a much different mirror system to cover more area.
Right.
Because what I want to see if I can do is I'll keep this device at 8 clicks, but I'm going to look at making a device that goes 12 or 16 clicks. So I can go 100, 200, 300, 400, all the way through 1600 MOA. Okay. Then that high-end version, what I would do is take and build it so the delta now attaches to as a Lego to this piece and is not part of the rail. Because therefore, I control the angles and distances. Versus it gets to a person, if they put it in the wrong place, wrong distance, wrong height, then it's like, holy crap, the chase is on. And I can't have everybody, well, you can, and I could charge people, but it's not my intent. Send me your gun, I'll fix it for you. I mean, you kind of think about it. People don't think about that.
Right.
I'll send a gunsmith to rebarrel my gun, but I won't send you my gun for you to put a custom optic on. You go, huh? Which one actually is almost harder on the gun? The custom optic, which has to look around, do this, look at this angle, everything has to line up. It's, you know, chambering is becoming pretty much an A, B, C, D, you know, as people have gotten so good at it. The optics, not quite there yet.
Yeah.
You know, so the next generation will pick up deltas that will fit directly to Charlies and or Mark 12s, Mark 16s, or Mark 8s. Therefore, if a person wants to do, this has to follow this preset angle, and that's one of the things too is the angles that we're doing, and I'm hoping a single modified mirror will allow me to run one angle. I'm hoping I don't have to do two. If it does, that means I have to further Lego this, that one out, one in, take this off that, or hate to say it, if it comes down to worst case scenario, you want to shoot 1200 MOA, it's a second unit.
Right.
Because there's no easy, it's getting so cumbersome that pretty soon you don't do anything well. You know, you want to be good through, and then say, if I have to do it again, okay, it is, you know. But we're going to make a swing at the fences and see how close we can get to. We know we can change, we can increase the range. We know that, okay. Now it's just called how cumbersome will it be?
Right.
You know, just because you can look at on a lens bench It's not the same thing as when it's all closed up in a piece of aluminum sticking on a gun. You know,
It's a big difference.
it's a big difference.
Plus, you're taking the force of each rifle shot. You have to figure your internals to
Oh yeah,
handle
things
that.
things have got to survive.
Yeah.
You know, it's the adhesives and stuff we use in these. When the lenses go together, it's a one-way trip. I have no efficient way to get these things apart, if at all. Sometimes, if I put in certain solutions, 6 weeks later, I might get something to come partially loose. Might.
Well,
Other times, 6 weeks later, yep, looks the same. So, I mean, technically, the lenses themselves could go into gasoline. You know, we use some silicones for temporary bonds to make dams and keep things in place. But after that, the other adhesives they're pretty well
yeah.
proof everything.
Because I think that's one of your cleaning solutions, is just dip it in gas.
No, you can. I wouldn't, but you can.
Yeah.
Okay, but standard cleaners, wiping it won't matter, because now the reason that we can't do this is the seals on the bearings. They would not like
They wouldn't like that.
gas.
No.
Okay, the immovable one, yeah, you can about do anything you want with it. It ain't going nowhere. Okay, so yeah, a bit of a learning curve.
Yeah. I know my Delta, you have that on quite a
It's a
big
big
angle, so
yeah.
when the rifle's sitting up.
I got lucky on yours. If it needed any more, I was gonna about be done.
Well, you said you broke two.
I broke two. Oh
Deltas.
yeah, because machine your pieces, you know, it was. I had never, until now, had thought about I'm gonna re-grab a Delta and do major machining on surfaces on the side. Well, I don't have fixtures because I never was gonna do it. Okay, I have wedges that go to this, but they're kind of standard stuff. You took a completely different avenue. So now, and it got to the point that when I broke the second one, I'm like, I should have just built a picture.
Yeah.
Because I don't, you know, when I look at a body, I go, I got 6 size machining. 6 size machining. You know, it doesn't take long to go, this is getting expensive.
Yeah.
Really, really quick.
Yeah.
So, yeah, your pair, we might have eked a little more out of it, but at that point, we're actually starting to cut in the main body, and I was going to start losing edges and you know, surface and so on. So I got lucky.
Yeah.
Okay, that's why I know where the limit is. That's why, and all the concepts we did there, what I have designed for this, it says it will work. It will work. You know, it's not maybe not. It will work, and yeah. So.
Now you also had to redo all your calibration equipment
I sure did.
to make.
Because the angles were getting so large that the equipment was designed from day one to run gigantic numbers, angles, definitely past 45 degrees. You figure on these weapons, at about 41 degrees, we're not going any further. And technically, where you're shooting, you're no longer talking highs and lows. You're talking long shorts. And that's how I think the ballistic computer should be looked at. As it hits your numbers, you need to act like an artillery, long short, because you can't see high. If you go down range, let's say we're only shooting 2 miles, be a spotter at 2 miles. Guy's down there shooting at it, and for him, he's seeing a miss by this much. You know, it's right over the target. It's 100 yards long. That's what the little thing is, depending on the slope of the ground and everything.
Yeah.
So it's called no. How do I bring it in 100 yards? What's that dial in? Or
Right.
75 yards, because you don't have reference to your height anymore. Or short. Oh, you're 1 target short. No, you're 200 yards short.
Right, that happened on my 3 mile shot. My
Yeah.
kid's like, you're 2 targets low. I'm like, no, I'm not. I'm 300 yards short.
Yes, yes. And, you know, so although it was built, I hand set it up for the fixtures to actually do it. And, yeah, I had done very good for a few days there, making sure as I moved, I was actually having to tape reflective surfaces into place so they wouldn't slide off.
Well, you said you broke 2 mirrors.
I did, because I forgot to tape it down. Got going, and also went stink.
Here's $500.
Yeah, And yeah, before I ever do that again, it's not only change that surface and how they're held, but it's going to get rubber on the bottom, so at least it has a chance of bounce. Whereas right now it goes steel, glass and steel.
Steel wins.
It usually wins at some point. So yeah, there was a few moments there. I was crying that first time out when the Delta came out, because it was the devices. The Delta's light enough now that if I grab it, I can't grab it hard because I'll collapse it. And if I collapse it, it's sprung, and now I can't get components into it. And so on the first time was machined the wrong direction for how it was being held. My mistake, trying to cheat. And out she came. It came out. The cutter came out. It was one of those times it caught the cutter just right as the cutter. You heard a snap in that cutter. It was a little missile as it flew across the room. You know, the guy
Look around, make sure you're not bleeding.
The guy behind me ducked because he never saw one blow up that bad.
Yeah.
So I was like, yeah. I walked more. I said on the big machine. I said, see these dents? I said, it's not some midget in there beating him with a hammer. I said, there's a guy. Something came apart.
Yeah.
And you think about all that force that it's grabbing something. And,
well, it's spinning pretty quick too.
Oh yeah, you're spinning. You got horsepower sitting there.
Yeah.
It's
absolutely.
launching. So it's its own little gun. You know, as it goes winging out. So yeah. So I went through a couple. I will now go ahead and build fixtures to grab these angles. And I'm going to think if I even need to, because the way I want to build it, can I make Legos? You know, I think a lot of times it's easy to have a solution that's complex. No, go make it. But there's no thought of it. Can I build it again? Can the next guy use it? Can it be repeated?
Right.
That's the complexity side.
Yeah.
Versus simple. You know, how do I get to simple? And sometimes that's hard. If I'm in the zombie world, do I want the newest GM with the best computer in the world floating around, or would I like to have an old, mechanically driven Cummins diesel?
Yeah.
Because it will start and run no matter what. And it goes around that computer, oh, you're done.
You're done. Yeah, sensor's bad.
No, you're done. Anything goes,
60s
O2 goes bad. You're done. Anything.
Yeah.
Anything. It's a done deal. Shorts, a little water in the wrong place. And I look at that.
Keep the costs down too.
And as I get to
think.
simpler, yes, it does. Back to manufacturing. I can't be the only guy as I build these. I'm the only guy who can build it. That sucks.
Yeah.
You can't get parts up there. You can't do this. And also, I can't have. Well, there's trick A, trick B, trick C, trick. You can't write enough down. You almost can't video enough. To say, oh, but this little step right here, you got to do this. Otherwise, it don't work. One of those bits. And as even on this one, it has some pretty one-way dones. It's done. It's done. 24 hours later, when you come back, if it ain't right, throw it in the garbage. Because by the time you get it apart, re-clean all the surface, all that, it's like, hey, this ain't working.
Right.
So simplicity is really important to me. Simple things. It's all carbide index points. It's tool steel guides. How I set the guides as compared to each other. It's meant for self-location and so on. It's meant to be dumb, simple, that within reason, I could teach an armorer how to build this. Oh, it got full of grit. This went wrong. Here's a parts kit. Okay, put it back together. And because of the way it's set up, technically a person can do that pretty easily because there's almost no way to permanently mess up the surfaces in here. Almost none. I mean, let's put it this way. The softest material in there is A5, hard A5. That's the softest.
Yes. When I was videotaping the last time I was here, we were talking about your barrels, and you had a bunch of Mark 8s laying out, and the adjustment bolts, they had the carbide tips on those and stuff. You were showing me the different hardened metals.
It just makes it simple.
Mm-hmm.
It
doesn't wear out.
It doesn't wear out.
Yeah. And my setup, this is what you use to mock up mine on.
Yeah.
Is this a 22 degree?
It is.
Setup, yeah. So mine, what was funny, when you mailed me mine, I opened it up, I put it on, and it was set at 700 MOA. So I looked through it, and I'm like, oh, the image is beautiful. I text you back. So I had to build something to shoot off of, and my bipod won't give me that angle. So I'm like, okay, I lifted it up, I put the level on there, got my angle, got a measurement, so I started building the table. And I thought, you know what, I might as well put everything on and check it out and see how it feels shooting from behind, behind the scope, looking through it and everything. And then I started dialing it up, and I got to like 10. And I'm like, uh-oh, 1,000 MOA. I lost half the thing. I flipped to 11, and I called you. I'm like, what do we do? So you gave me some ideas, and sure enough, I ended up putting my old mounts back on and raised the scope up, and
that information, I love working with people who have mechanical ability, because I'm more than happy to hear what they have to say.
Yeah.
Because they're doing things at a different viewpoint, different tools, different, you name it. Well, that difference is, if you start working on it, you get a robust system. If this only works on one scope, one height, well then what's the point of that?
Right.
You
lose a lot of your market too.
It's just a horrible thing. Versus, and I should have thought about that. The reason I jumped you on the scoping, because where this one sat. You had 2-inch rings. This is 1 3/8. I'm looking at 1,300 MOA through this. 14 failed, right? The 13 I had a clear image. So first thing I'm thinking, no boy, 2 inches. Let's just get a set of rings here just in case.
Right. Yeah.
Because your timeline was short.
Yeah. Exactly.
You can send the rings back. I would actually buy the rings from you.
No, I was going to put them on my 338.
Okay, there you go.
Because it gives me a lot of travel.
Yep. It gives you some.
And they're a really nice set of rings.
They're a nice set of rings.
I like the little tool they give you to level
out. It's close. People got to look at that.
Yeah.
That tool puts you close, but that doesn't mean the reticle itself is true to what you think the machine axis of the scope is.
Yeah.
You still need to square up the gun, square up the scope, and find a vertical.
Yeah.
Just make sure it's true.
Yeah.
Otherwise, you start moving these big
I'll drop
numbers.
plumb bobs and look at the string.
You start moving these big numbers. Let's say 1/4 MOA.
Yeah.
Well, 1,000 MOA. What's a quarter add up to? It starts getting out there.
But yeah, you're getting out to 8,000 yards. That's
That's
20,
a football field.
20 something. Yeah.
Just an error.
Yeah.
Oh, now there's some wind.
Well, that's the whole other thing. I was shooting 2.1 miles and 40 mile an hour wind. It was killing me.
One thing that people are going to think about when they go onto a rail, and I forgot to send it with you, is the front rail on a lot of guns is not exactly square. It's the rear rail. And you go, oh, it's within a few thousandths. What did you just say? Okay, 1 degree is 17 thousandths per inch. A 1/4 MOA is 4 thousandths per inch. How wide is that rail? Let's say it's 5/8. Oh, that means that rail has to be within 2 or 3 of square of the other one. 2 or 3 is it within 2 or 3?
Right.
If it's not, it means we're pointing somewhere else. So therefore, the easiest way to do these is you break it loose and you put a piece of shim. Let's say the mount here. You put a piece of shim on your low side, bring it back around, tighten it down, because now it's set to the rifle. Because we squared up to the auto collimator. The auto collimator is square to itself. It doesn't know that there's an unknown rail or anything. It just goes,
right.
I'm square. So it doesn't matter what it is. It doesn't matter if it's a Bravo, Night Force, or anything. You need to check that square. Where did it go? And the way you're going to do that is not only do I look through the image, if it's square, but let's go right up that, and see now you're seeing your full movement, your full travel. Because let's say I'm looking at my scope and I'm looking at, let's say at 30 MOA of view. Well, 30 MOA, and I got to dial it 3 times. Well, I'm plumbed up here. Well, if I'm off a little bit, 30 goes, now I got a gap. Well, you want to know what that is. No, I think Kestrels can dial out cant to small numbers. And if you know it, dial it in, and you don't have to do that. But to me, that's the same thing. If I mechanically take it out, then it's forever. If I put it in an electronic device, next gun I build, oh, I forgot to put that in.
Right.
And you're off again. Right.
Interesting. It's definitely, it's a lot of thinking and fooling around, making different parts and pieces and experimenting to finally get to your end product too.
Yeah.
So I appreciate you rushing through, getting mine ready. It was, I know you're putting a lot of hours in on that.
Yeah, you know, it's like a lot of new things. What you think is going to be the setback, half the time becomes the easy thing.
Mm-hmm.
It's a thing you didn't expect that you go, oh crap. It really gets out of line. You know,
Yeah, exactly.
like machining the foot. That should have been, I should have spent more time turning the mill on and off than I did. Instead it became 2 hours later, I'm still fighting with it, or my old collimator, as I'm moving and trying to find where it wants to look and see, because actually the collimator, it only has a view of 30 minutes. That's all. That's its full view, and I can measure down to a half arc second. Okay, so it gets pretty precise. But on the big stuff, same problem. If there's a gap, the image is somewhere.
Yeah.
I just don't know where it is. So the search is on, moving this, moving that, trying to find it. So a lot of the stuff I wind up setting a low number. Your 700 MOA. The reason that's sitting there on yours is because I took another Mark 8, set it up to get to 700 MOA, and I went, okay, here's where everything's set up.
Your starting point.
And now I got to start. I put that when I go. I got a starting point.
Yeah.
Versus 700 MOA. I'm like, I can't even remotely find that image because it's not only up and down, it's left and right.
Yeah.
Well, how much air does it take to go off 30 minutes? Not much. You know, I could a little twist this way, twist this way. You know, oh, the unit itself is off because I had to use that unit to get it lined up in the first place.
Mm-hmm.
So it's you wanted to get its starting point. So chances are I'm going to leave the Mark 8 floating around here. It sits by that machine that just starts at baseline.
That's a good idea.
To walk it up.
Yeah.
So otherwise, yeah, you can't. It's, you know.
Now, did you have to do anything different to get the 1400?
No.
No? All the mechanics and everything inside were able to make it.
Yeah.
Wow.
Yeah.
That's pretty good. A good thing you designed it with that much give or that much
yeah,
adjustment.
we did on purpose, and there's other guides that take place in there. So as you move up in value, though these are adjustable, you can't take, like your screw that's at 1300, 1400, you can't take, it will not sit at 100 away. Because there's other guides to get it to move, to allow it to move to those values, because you're starting to move the mirror a long ways.
Yeah.
You know, you figure you went from 0 degrees to 10 degrees of movement.
Right.
You know, so, yeah.
Pretty cool. Appreciate you taking the time to talk about this. It's good stopping by, visit you.
Yeah.
And thanks again, John.
Oh.
Appreciate it.
Well, thank you for the time and all the effort, and Jesus, you know, you drive all those hours to have that crap happen.
That's one of the unpredictables. Yeah.